welcome to episode 8.f. We're going to be looking at quadratic drag with vertical motion now. So this one is going to be simple. I'm going to draw a diagram. And actually, I'm going to draw it this way. So we have our y going downwards, and y going down, and we have our object being affected by gravity, and our velocity, and then obviously our drag force. So Newton's law, sum of our forces, my double dot, is equal to gravity minus cy dot squared. Okay, so just like in our original, in our linear case, we also have a terminal velocity. And so let's figure out what that is. So that's when these two are equal. Mg equals cvt squared. You know, we move stuff around. We find vt is equal to the square root of mg over c. And once again, we're going to use this terminal velocity to solve for this equation. So we're going to write gmg in terms of vt, and that is going to give us, actually we're going to write vt in terms of our terminal velocity. So what do we get? Well, we're going to write c, we multiply, so we get c is equal to mg over our terminal velocity, and I'm going to substitute that in here. So what do we get? So we get my double dot is equal to mg minus mg over vt squared, this is a square, forgot, times y dot, wrong color, times y dot squared. So what can we do? Okay, well, we have two m's, they cancel, and we can distribute this g outside, so this becomes g 1 minus y dot over vt squared. Y double dot. Okay, so once again, we're going to use separation of variables, and I'm going to use separation of variables to solve this differential equation. So we get y double dot over 1 minus y dot over vt squared equals g. And what is this? What is this term? And we're going to solve this integral. So if you're not familiar with this, this is actually the derivative of the arctan arc hyperbolic tangent function. So this actually becomes arctan of v, so v terminal times arctan h y dot over vt. So we use this property that integral from dx over 1 minus x squared over a squared is equal to a times the hyperbolic tangent of x over a. That's what we're doing here, right? And this is obviously equal to g times time. So we can do some more simplifications. We find, so this gives us x, or not x dot, y dot is equal to our v terminal times the hyperbolic tangent of gt over terminal velocity. Yes, and this is obviously our equation for velocity. You can solve this once more. Y minus y naught equals, and this is going to give us vt over g, and then obviously we have another vt squared because the derivative with respect to time of tan a over bx, right, is b over a natural log cosine x a over bx, right? You can prove that for yourself if you want. Should be standard from your calculus classes, and from after this, what we can do, vt squared natural log of cosine gt over terminal velocity, and then obviously we can solve for y. So y equals y naught plus vt squared over g natural log of the cosine of gt over vt. And this is our final equation for y in regard, right? All right, so hopefully that wasn't too bad. And yeah, next episode we're going to look at quadratic drag come with both vertical and horizontal motion, and we're going to find, I'm just going to describe it because we're going to find that there is no way to really analyze it because we're going to have two components for the magnitude or velocity. So I'll leave you to that. See you in the next one.